Okay, I just want to have a look now at SOH CAH TOA and recap that old favourite. If you remember, comes out of right angle triangles and reminds us about some results to do with sine, cos and tan. Remembering that if we're talking about an angle here, then that side there is its opposite side. This is the adjacent side, and this, regardless of which angle we're talking about, is the hypotenuse opposite the right angle. Okay, I just want to take us through, just remind us really about where SOH CAH TOA come from. So in order to do so, I'm going to bring this this little piece of software up here. Now, if you just observe what's going on, I've got a 30-degree angle here, and I've got BC, the opposite side, measured at 4.1, the adjacent side down here at 7.1, and the hypotenuse at 8.2. And what we're looking at is this ratio here, the division between 4.1 divided by 8.2, and as you can see, it's a half. Now, what I'm going to do here is I'm going to change the size of this triangle around, and you can see that these numbers all change, but what doesn't change is 0.5. And what we're fascinated by in mathematics are things that don't change when other things are dynamic. So as everything moves around there, the 0.5 doesn't change. So that means what else is not changing is this 30-degree angle here. So what we're able to do then is if we've got a right angled triangle and I can know that one of the angles is 30, then I can say with absolute certainty that the opposite over hypotenuse will be 0.5. Now you know the opposite over hypotenuse to be sine, opposite over hypotenuse, SOH. And if we put sine 30 into the calculator, I did this just a minute ago, we get 0.5. So the connection there is that because I know, regardless of the lengths of these sides, that the ratio will always be opposite to hypotenuse will be 0.5 for 30 degrees, then I can build a calculator and I can just program that in. That's all the calculators, it's just been programmed to say sine 30 is 0.5. Now, that's fine. What about when it changes? All right, well, let's change the angle. Oh, I don't do it like that, I'll change it like this. Okay, so the angle has changed to 38. And now the ratio is 0.616, but it doesn't, wherever these sides are at 38, it's 0.616. And so, all right, I get it. I'm going to put in here sine of 38 and hit enter. And I'll get, if I ask it for an approximation, 0.616. So that works for sine. Now, cos is a different ratio. It's the adjacent side of the hypotenuse, but the same thing applies in that you get a different result here, 7.788, but for a 38-degree angle, it doesn't matter what the lengths of these are, the ratio of adjacent hypotenuse will be 0.788, and that's backed up. If we put cos 38 in here and ask for an approximation, we'll get 0.788. And finally, to tan, which is opposite over adjacent, and I'm going to just change A back to 21-degree angle. Tan 21, we should get 0.38. So tan of 21 oh dear, tan of 21 degrees, close that bracket, hit enter. Got to go through all that. 0.384. 0.38 to 2 decimal places. Okay, so that's just a recap really of what the SOH CAH TOA means and why it is that we came up with this SOH CAH TOA result. Because we know that the sine of an angle will equal the opposite over hypotenuse, and that is a recorded value. So, cos of the angle will equal adjacent over hypotenuse, and tan of the angle will equal the opposite over adjacent. This is how to identify each of the sides in a right angle triangle. So with that information, we can take it into an example where we have an angle here of 56 degrees. I've got a length there of 15, and I can find now either of these two sides by using either cos if I'm asked for this side here, or tan if or sine if I'm asked for this side here, because this is my adjacent side, this is my opposite side, and sine deals with opposite. So if I was going to use, if I wanted the value of y, I would simply write my solution up like so and get y equals, into my calculator would go 15 by sine 56, if you remember, and away we go. 15 by sine 56, 15 times, go into trig, sine 56, hit enter, and we get 12.44 as a solution to 2 decimal places. If we have another, it's always with right angle triangles, this only works for right angle triangles. I now need to find out what an angle is, but I've got some information about the sides. Excuse me. I discover that I've got the opposite and the adjacent sides. So that is tan of this angle here is equal to 3/7, and the calculator will do it in reverse as well. If you go to the inverse function, tan inverse, and I can put in the fraction here at 3/7 and hit enter, and I will get the result of 23.2 degrees. 23.2 degrees. So just as it is able to tell me what sine, cos and tan of numbers are, it'll also tell me what the angle is if I put the ratio in, because it knows with a given ratio what this angle here must be. Excuse me, I just had a little bit of a coughing fit there. But okay, so that was just a little review now there of SOH CAH TOA, how it is arrived at through unchanging ratios, and how we use the calculator in order to make our calculations. Not a difficult task for us, but this will lead us into exercise 16D to go with exercise 16A for our next lesson. Okay, I'll see you then.